Hello, welcome to 9.6, which is the last section of actually the course. So that's very exciting. Congratulations, you've made it this far. So we're continuing with square roots. We're just going to solve equations with square roots. Let's get started. What is a radical equation? It's basically, it's not radical. Remember the 80s? For those of you that are old enough to remember, word radical here doesn't mean like cool. It means, although radicals are cool. Okay, basically it's it's an equation that has a radicand, right? Where the variable is inside. So let's say, like, for example, this. So when you have here a square root of x plus 2 is equal to x, is x equal to a solution? So for A, all you have to do is just plug it in. Is 2 plus 2 equal to 2? And it's square root of 2 plus 2, which is square root of 4, which it is, right? This 2 equals 2, so that's fine. So yes, this is a solution. Is x equal negative 1 a solution? So does the square root of negative 1 plus 2 equal negative 1, right? Because we just substituted in for x, right? We substituted this part, here, right? Okay, so then this is square root of 1 on the left-hand side. Negative 1 stays the same. Square root of 1 is just 1. Does 1 equal negative 1? No. So this is not a solution. So let's do another one. Is x equal negative 2 a solution? I am already, we know that, we don't know actually. So I am going to bite my tongue for a second. So they do not equal, right? So this is not a solution. Is x is x equal 3 a solution? Square root of 3 plus 2, square root of 3 plus 6, is that equal to 3? So that's going to be square root of 9 equals 3. So 3 does equal 3, so x equals 3, yes, it's a solution, okay, because both sides are equal. Okay, so how to solve an equation, radical equation? You basically, similar to where you isolate the variable, instead you're going to isolate the radical, and then you take the square of both sides and you simplify, right? So let's say, for instance, and we're using this property here, that the square root of the square of a square root is back to the root, right? It's equal to, a, whatever's inside the radicand. So let's go ahead and do an example. So first thing we're going to do is square both sides, because this is already solved. The radical, we want it to be like radical equal blah, 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 So now that we have like that, we can square both sides, and we get, this cancels out. So you just get 2x minus 1 on the left-hand side, and on the right, you get 49. So then we just solve for x, right? We get 2x is equal to 50. Divide by 2, divide by 2, we get x is equal to 25. And that's it. All right, let's try another one. We have square root of 5n minus 4 minus 9 is equal to 0. Well, we don't have the square root by itself yet. So we're going to add 9 to both sides. Then that will leave us with square root of 5n minus 4 is equal to 9. Now we square it, both sides. So what does that do? So this cancels out here on the left-hand side, and we get 5n minus 4 is equal to 81. 9 squared is 81. And then we solve for n, so we add 4 to both sides. Sorry, what the heck is this? So then this will cancel. You get 5n is equal to 85. And then divide both sides by 5. And you'll get 5 is equal to 17. 5 is equal to 17. N is equal to 17. What is wrong with me? N is equal to 17. After dividing 85 by 5 gives you 17. Okay, fine. Let's do another one. Let's do this guy here. We have square root of 9k minus 2 plus 1 is equal to 0. If we solve for the radical here, we subtract both sides. Square root of 9k minus 2 is equal to negative 1. So this already we can tell that it's no solution. So remember in the beginning, the ones that were negative were not a solution, because you can't take a square root of a real number and get something negative. That's impossible unless for real numbers, okay? So emphasis on real numbers. We can't do this because what number can you think of that when you multiply by itself, it becomes negative? That's impossible. The choices are either you multiply positive times a positive, that's positive. A negative times a positive is going to be negative. Positive times a negative will give you a negative, and a negative times a negative is a positive. This is just property of like real numbers. So for the solution to be negative, one has to be minus and one has to be plus, but that doesn't apply like for the square root. There, it won't be the same number, right? What is the definition of a square root, right? So square root of A is equal to B, right? When, you know, A is the root squared, right? It has to be multiplied. This number has to be multiplied by itself in order for it to be true, and you can't have that. So you can't multiply a negative number times itself and get a negative number. Negative times a negative is a positive. In other words, so when you see square root of something is equal to negative, you can right away say no solution. Okay? All right, so what if they get a little bit more complicated? Well, if you get them, they get more complicated, it's fine. You just have to isolate the square root. So let's go ahead and do that. So you get square root of p minus 1 on the left-hand side, and then p minus 1 on the right-hand side. We square them. So this will cancel out. On the left-hand side, the radical cancels out. So you get p minus 1. On the right-hand side, you see that it's a perfect square trinomial, right? So first term squared minus 2 times the product of p and 1, that's just p. And then plus the last term squared, that's just 1. So now we're here. Let's solve this for 0. I'm going to subtract p and add 1 to both sides. So that cancels. You get 0 is equal to p squared minus 3p plus 2. So then you ask yourself, what are the two factors of positive 2 that give you negative 3? And it's negative 2 and negative 1, right? Negative 2, negative 1. And so that's it. So your final answer will be p equals 2. P is equal to 1. Yep. All right, let's do one more of those. So then let's say here we would add r to both sides and subtract 2 from both sides. So you would get square root of r plus 4 is equal to r minus 2. Square both sides. This will cancel. You get r plus 4 is equal to, this is perfect square trinomial, first term squared minus 2 times the product, that's 4r plus 4, minus r minus 4 minus 4, right? We get 0 is equal to r squared minus 5r. And these cancel out, actually, so that's it. Factoring, we factor out the GCF of r, okay? And so now you get two answers. R is equal to 0, or r minus 5 is equal to 0, which means that r equals 5. Okay, great. So that's it for this one. What about here? If you have a coefficient in front of the radical, we need to square it as well. So sure, so now we need to get the radical by itself. So we get 3 square root of 3x minus 5 is equal to 12. Now, could we just get rid of this coefficient? Yes. So if you do that by dividing both sides by the coefficient, if it fits, right, then you even have this a little bit more clean. This is nicer, right? So now you can square both sides. And you get 3x minus 5 is equal to 16. And then solve for x. Now, what if it didn't divide nicely like that, like how it is now, right? Like, what if it was something different where you have, this is x equals 7, where you have like, let's say you had 7 square root of x minus 1 equal to 12 or something. Then you wouldn't divide by 7. I mean, I guess you could, but if you square this side, it has to be, you would square both sides. You would have to make sure that you square this too, so that would be 49 times x minus 1 for this one. So just so you know, I'm not going to complete it, but you can do it. And, okay, so let's do a few more. Okay, here we have square root of 4z minus 3 times the square, equals square root of 3z plus 2. So if we square both sides, I don't know why I wrote 3. If we square both sides, this will cancel the square roots. So you just get 4z minus 3. This is actually an easier one than the other ones, right? So we would add 5 to both sides and subtract 3z to both sides. Okay, so that becomes z. Wait, why did I add 5 to both sides? That's so weird. Sorry. This should be a 3. A 3. And then that cancels out here. You get, oh, I must have been thinking about the solution. 5. So the solution is 5. So z equals 5. So that's a nice one, right? Let's do one more. What about something like this? Oh my goodness, what's this? So here we would square both sides. Okay. And then on the right-hand side, you see that we'll just get rid of it. That'll be m plus 9 because the whole thing is squared. But this right here, only this part is squared. Notice there's not a square root of the whole thing, so it's a binomial. So then you have to go ahead and do, perfect square trinomial. Recognize it. We don't have to. I guess you could still, use the box method and multiply the two binomials together, but it's kind of a lot of work. If it's so much easier just to remember this. 2 squared of m plus 1. So then this becomes m plus 2 root m plus 1 equals m plus 9. So I'm going to move everything. I'm going to use the properties of equality, right, to just get the isolate the radical. So we get 2 square root of m is equal to, this becomes 8. Oof. Then, it works out. I can divide by 2. You get square root of m is equal to 4. And now square both sides. You get m is equal to 16. Okay. So let's do another one. This last one here. So we square both sides here. Okay. It's still not, we're still just using, on the left-hand side, it's a binomial because the square root, remember, notice the square root only applies to this. In order for the square root to cancel, it has to be squaring the entire, has to be covering the entire side of the equation, if that makes sense. So, sorry, this is going to be equals, I'm just writing down what I'm using, b plus b squared. Okay, so on the left-hand side, you have square root of q minus 2. That's going to be my a, right? Plus, and then twice the product, so 6 square root of q minus 2. Plus, and then the last term squared, that's going to be 3 squared right here. And then on the right-hand side, you just get 4q plus 1, okay? So then here we simplify, we get q minus 2 plus 6 square root of q minus 2, and then plus 9 equals 4q plus 1. How about like terms over here? So we get q plus 7 plus 6 square root of q minus 2 is equal to 4q plus 1. So we need to move all the q's over. We need to isolate the radical again. Okay, so we get 7 plus 6 square root of q minus 2 is equal to 3q plus 1. So then minus 7 minus 7. And we get 6 square root of q minus 2 is equal to 3q minus 6. So then if we, that's okay. Let's just square both sides here. So you would get 36 times q minus 2 is equal to, and then this is going to be a squared minus 2ab plus b squared. So this is going to be 9q squared minus 36q plus 36. Okay, so then we're just going to distribute this here and solve for 0. Oh boy, so I'm going to write it up here, I guess in pink. I don't know. So then this is going to be, so this is where I'm going to start here. Okay, so I have 36 36q minus 72 is equal to 9q squared minus 36q plus 36. 36, not enough space, plus 36. Okay, so then now let's move everything over. Minus 36q minus 36q, that's a q. So then you're going to get negative 72 on the left-hand side, that's a q, sorry, is equal to 9q squared minus 72q plus 36. So add 72 to both sides. Okay, we get 0 is equal to 9. My 9s look like q's today. 9q squared minus 72q plus 108. Now, notice everything's divisible by 9, so I'm just going to make life easier for myself. Divide everything by 9. 0 divided by 9 is 0. Here, this becomes q squared minus 8q plus, let's see, plus, what is 9 times, what is that? My brain just like, it's 12. You know, it ever happened where your brain just kind of goes blah. Okay, 12. Okay, so then now we factor q minus 6, q minus 2, right? And then your answers are 2 and 6. So that's it. Okay, that is quite a bit. So let's go ahead. That's it for the section. And that's it. That's your homework. So congratulations. You're done with the videos. Good luck. Study for your final. And happy studying. And I will see you in Math 80. Good luck.